Hello everyone, my name is Jania Kusina Rahman, and in this time I would like to explain about the report of subnetting, VLSM, and static routing. And we will talk about the table of contents. In this chapter, we will talk about VLSM, subnetting, and static routing. But in this material, I display more than that. I also explain about FLSM, VLSM, IP ver 4 and IP version 6, subnetting and static routing. And about the problem formulation, for the first one, the main topic is how do the concept of subnetting and VLSM can help us to dividing an IP network into several subnets with different numbers of hosts. The second one, how to determine the network address, broadcast address, first host, last host, and each subnet with the VLSM method. And the last one, how are the results of VLSM calculation applied to a network topology, and how is connectivity between subnet configured using static routing. And this is the theoretical that I use. For the first one, I will talk about FLSM. FLSM, or fixed length subnet mask, is a subnetting method that functions to divide existing network address into several network address. And VLSM is an advancement of subnetting mechanism where VLSM addressing the limitation of classical subnetting, IP number allocation is inefficient. And about the subnetting have a lot of function. For the first one, IP address conservation allocates limited IP address more effectively. As you can see in the screen, there are a long of explanation about the function, but I will talk about it with effectively. And subnetting ensures that traffic intended for device within a subnet remains within that subnet, which reduces latency. And third one, by separating your network into subnets, you can control traffic flow using SELS, QoS, or route maps, allowing you to identify threats, entry points, and target your response more easily. For the fourth one, optimizing for network performance. Even if an organization has thousands of host devices, operating all of these devices with the same network ID will slow down the network. And the last one, static routing. The main function of router is packet forwarding, which is the process of forward or sending data packet to the destination network, obtained from the destination address of each packet. To do this, the router needs to find route information to the destination network into the routing table. And I will implement those all theory in this chapter, which chapter 3. And in this practicum, I will discuss the application of VLSM in computer network design and addressing. And for the first one, we have to determine the network address, broadcast address, first host, last host of the IP address with VLSM calculation. For the first one, I will make this table that is host requirement table. The host requirement table shows the number of devices to be used on each subnet, one network. From this table, it can be seen that the host requirement for each network vary, ranging for network with a large number of hosts to network with a relatively small of hosts. And the most high use of this subnet is subnet C, subnet B, and A. And then after make the host requirement table, I make this following calculations so we can see how the subnet mask can be found. And this is the table of VLSM, subnet A, subnet B, subnet C. Subnet A requires 14 hosts, subnet B requires 28 hosts, and subnet C is the network with the largest host requirement, namely 45 hosts. And this is the 1A, 1B, and 1C. 1A is a network with the fewest host requirement, and 1C is used to connect the network between routers and requires 10 hosts. And how we configure the topology? For the first one, we have to open the Cisco packet tracer and then add network devices according to the specified topology, namely several routers to connect subnet at one networks, switches to connect device within a single subnet, and PC as end device on each subnet. And this is the topology that I'll already take. After all devices are in place, the next step is to connect device using the appropriate cable. PC to switch using copper straight through cables, switch to routers using copper straight, and routers to routers using serial DC cable. And this is the result. Serial DCE cable seems different because we use it to connect the port must be on serial 2/0 or serial 3/0 and cannot be on any other port. And after all, I will configure the IP address on each PC in each LAN network. Why I made this table is to remember what PC or what IP address I've already used because sometimes we can forget it. So I think this is the appropriate way to remember it. And this is how I entry the IP address on each PC. And beside IP address, I also add the subnet mask and default gateway because it's also important. But the DNS server is not that important. So in this case, we will not use DNS server. And after all PC already have their IP address on router device, each interface is configured with an IP address that corresponds to the connected network. This configuration allows the routers to recognize all connected networks and forward data packets to the correct destination network. As you can see, on router 0, the IP configuration is done, and the fast Ethernet interface that is directly connected to switch 0 and PCs on subnet A. This interface acts as a gateway for all devices on subnet A, and the IP address used to route interface and adjust subnet A network. And we do the same way on the router 1 and router 2. After we configure all of the router, I also do this thing. We will connect the 1A, 1B, and 1C with this following way. The serial connection between router 0 and router 1 is used to connect subnet A directly to subnet B, and the serial interface between router 1 and router 2 is configured to connect subnet B with subnet C, and the serial connection between router 2 and router 0 completes the inter-router communication path in this topology. And we use the serial 3/0 and serial 2/0, and that is different between the configuration and serial configuration. And in each router, I will assign an IP address with the same network as the small subnet or one according to the VLSM result. The IP address in the serial link function as a point-to-point communication link, allowing data to be sent directly from router 0 to router 1 without passing through other networks. And the no shutdown configuration is performed to activate the serial interface and make it usable. And after we configure all of those routers, we can check the ping on the PC. I will perform a ping test to verify whether PC on the different one can communicate effectively, and the result is all successful. This means that all router configured have been successfully complete. And this is the conclusion about my practicum. And this is the reference that I use. I use 6 reference. Maybe that's all I could explain. I'm so sorry if I have a lot of mistakes on this practicum. Thank you for watching. See you on the next practicum. Thank you.